Hey guys, today's day 44 and today we are going to learn how to solve systems of equations using the substitution method. So last class we learned to solve by graphing. So we started with a warm-up. So if you haven't printed out the warm-up and tried it, you should do that right now. I'm going to go over it. So I'm going to go over it kind of fast. But the first two lines are in slope-intercept form. So for the first one, my slope is 2, my y-intercept is -8. So to graph it, I start at -8, 2, 3, 4, 5, 6, 7, 8, and my slope is 2. So I'm going to go up 2 and over 1, and there's my line, or starting to make my line. There it is. Okay, now the second one, my slope is going to be -1, and my y-intercept is 4. So 1, 2, 3, 4, and then I start going down 1. Okay, so I'm interested in the point where the two lines intersect, which is right here, and that would be at 1, 2, 3, 4, 0. Okay, so I can take that solution 4, 0 and plug it into both equations to do my check step. And if I do that, y is equal to 2 times 4, which is 8. 8 minus 8 is 0, so that first one works. The second one, my y is 0. Does that equal -4 plus 4? Yes, that works as well. Okay, so number 3, we're not in slope-intercept form, so we're going to start by putting it into slope-intercept form. I'm just adding 18x to both sides, and then I'm dividing both sides by 6. So in slope-intercept form, I get 3x plus 4. So to graph that, 1, 2, 3, 4, and my slope is 3. 1, 2, 3 over 1. Okay. All right, so I've got my line here. All right, the second one, I'm going to put that into slope-intercept form. I've got a -y equals -3x minus 2. I just subtracted 3x from both sides. Now I'm going to divide both sides by -1. So my y is equal to 3x plus 2. Okay, so if you notice, my slopes are the same in both lines. So 1, 2, 3 over 1. So what's going to happen is I'm going to have a parallel line. Okay, and if the lines are parallel, then we know, because see, the y-intercepts are different. So those are parallel lines, so there's no solution. Okay. All right. Number 2 here, 2x plus y equals -3. I'm going to put it in slope-intercept form. Y is equal to -2x minus 3. And then when I graph it, 1, 2, 3, so my slope is a -2. Down 2 over 1, it's going to look like this. Okay, now the second line, I'm going to put that in slope-intercept form, so 3y is equal to 6x plus 3. Then I'm going to divide by 3. So my y is equal to 2x plus 1. All right, so I'm going to go down 2 over 1. All right, so it's going to look like up 2 over 1. All right, so I'm going to cross here at -1, -1. So that would be my solution right there. All right, if I plug it in to do my check step, I've got -2 minus 1 is -3, so that one works. And then I've got 6 minus 3 equals 3. So that works for both of them. All right, number 4. I'm going to put the first one in slope-intercept form. 2y equals -x minus 4. I divide by -2. My y is equal to 1/2 x plus 2. Okay, so I'm going to go up 1 and over 2. All right, so I've got my line here. Okay, if you notice, the second equation is also 1/2 x plus 2. So what's going to happen here is the lines are going to be right on top of each other, which means there's infinite solutions. All right. Okay. All right, so that's an example of the warm-up. For homework, you should have completed 43B. So if you want to go out to Schoology and look at the answer key that's out there, you can check your homework. But let's get into today's lesson. So today's lesson, we're going to learn to solve linear systems by substitution. So the first thing we want to do is solve one of the equations for one of its variables. Okay. It's going to seem a little confusing at first. When possible, solve for a variable that has a coefficient of 1. All right, and the coefficient is the number before the variable, the x or the y. All right, you're then going to substitute the expression. So you're going to get an expression that you're going to substitute that expression into the other equation and solve for the other variable. You're then going to substitute, all right, the value of step 2 into the revised equation from step 1 and solve. And then you're always going to check your answer. So this seems very confusing, but let's try it with some examples here. All right, so we have a linear system. Again, a lot of times you have a little bracket showing your two equations. If you have two equations, you're going to have two different variables. In this case, the first equation, and then we have the second equation. All right, so the first thing we want to do is look for a coefficient of 1. All right, so by coefficient of 1, I mean I'm looking at the y here. There's a coefficient of 1 right there. There's a 3. There's a coefficient of 1 right here in front of the x, okay? So in this particular case, though, it's actually easier to solve the first equation for y because it's already solved for y, okay? So your whole goal is to either solve for x or y, and equation 1 is already solved for y. Equation 2, we could solve for x by bringing the 2y to the other side, but it's an extra step. Now, to me, this is key. When you solve for x or y in the first equation or the second equation, I want you to circle that y in the second equation or the first. Okay, so in this case, we solved for y in the first equation, so we circled the y in the second. This is where the substitution is going to take place. We're going to take this expression, 3x plus 2, and now we're going to substitute it in for that y. Okay. So we're going to take the 3x plus 2, and right here we've got x plus 2 times, instead of y, we're going to put 3x plus 2. And then we have the equals 11. Okay, so that's a critical step right there. Now we only have one variable. We can go back to what we've learned in the first quarter on DC Mam, how to solve for x. So again, it doesn't go away. We're going to distribute. Okay, so I distributed. Now I'm going to combine my like terms. I've got 7x plus 4 equals 11. Then I'm going to subtract my 4 from both sides. So 7x is going to be equal to 7. I'm going to divide by 7. X is 1. So that should be pretty easy by now, solving for x, because we've got one variable. Okay, so we got our x. Remember, our solution is an ordered pair. So we know it's 1 and then something else. So we're more than halfway there, because we take that x now and we plug it in to this first equation. Y equals 3x plus 2. Or you can just think of it right here. So it's 3 times our x, which is 1, plus 2. 3 plus 2 is 5. So our y is 5. So there's our solution, 1, 5. Okay, and just like with graphing, you can plug the values in and do your check step. So our check step would be 5, which is my y, is equal to 3 times x, which is 3 plus 2. Does that work? Yep. And it's going to work for both. So my x is 1 plus 2 times my y, which is 2 times 5 is 10. Does that equal 11? Yep, that worked for both. Okay, so that's an example of substitution. We're going to do some examples. All right, so again, this was just a continuation of your notes we just did. All right, so looking at solving linear systems by substitution practice. All right, so here's our system. Now I look at the first two equations and I can see that right here I've got a coefficient of 1 for my y. So I am going to actually solve for y. And I did it by adding 5x to both sides. So I took that negative 5x, I crossed the equal sign, I made it positive. Because I solved for y in the first equation, I'm going to circle the y in the second equation. And that's where I'm going to substitute in the expression 5x minus 2. So negative 3x plus 6 times my y is 5x minus 2. And that's going to equal negative 12. All right. Now I've got one variable, so I can solve for one variable by distributing. All right. I'm going to combine my like terms. So I got 27x minus 12 equals negative 12. I'm going to add 12 to both sides. So 27x is equal to 0. And when I divide 0 by 27, I get x is 0. Okay, so again, halfway there, I take that 0, I plug it in to get my y. My y is equal to 5 times 0 minus 2, or my y is negative 2. So my solution here would be the ordered pair 0, negative 2. All right. Again, I'm not going to forget about my check step. All right, so I'm going to do my check quickly over here. I'm taking 0, -2, I'm plugging it in. -5 times 0 minus 2, does that equal -2? Yep, that one works because 0 minus 2 is -2. And the second one, -3 times 0 plus 6 times -2, does that equal -12? Yep, that one works too because -12, oops, -2. -12 is equal to -12, so that works. So my check step worked. Okay. Now looking at number 2 for an example, I look at my coefficients, and here I have a coefficient of 1 for x. So I'm going to solve for x here by bringing the 3y to the other side, -3y plus 1. Because I solved for x in the first equation, I'm going to circle the x in the second equation. All right, and I'm going to substitute in. I've got -3 times -3y plus 1 minus 3y is equal to -15. All right, I'm going to start out and distribute. I've got 9y minus 3 minus 3y is equal to -15. All right, now I combine my like terms. 9y minus 3y is 6y, minus 3 is -15. I add 3 to both sides. 6y is equal to -12. I divide by 6. My y is equal to -2. All right, now to get my x, I simply take it and I plug it back in to get my x. My x is going to be equal to -3 times -2 plus 1, or 6 plus 1, which is 7. All right, so my ordered pair is going to be my x comes first, 7, -2. And there's my answer. Okay, and for purposes of time in the video, I'm not going to continue to do my check steps. However, you can look at the answer key that's on Schoology and look at the check steps as they're verified. All right, example 3. Okay, now I look at my 2 equations. I find it's easier to solve for y. I've got a coefficient of 1, so y is equal to 5x plus 19. All right, I brought the 5x to the other side, and because I solved for y here, I'm going to circle my y in my first equation. So I've got -3x minus 8 times 5x plus 19, and that's going to be equal to 20. All right, I'm going to start out and distribute. Okay, oops, that should be a -152. Sorry about that. Let me get that. 8, 7, so it should be -152 is equal to 20. All right, I'm going to combine my like terms. I've got a -43x minus 152 is equal to 20. And then I'm going to add 152 to both sides. So I end up with -43x is equal to 172. So when I divide by -43, okay, my x is going to be a -4. All right, I plug in my -4 here. Okay, and my y is going to be equal to 5 times -4 plus 19. So that gives me a -20 plus 19. So my y is -1. So my solution is -4, -1. Okay. All right, so I quickly do my check step, and 3 times -4 is 12. 12 plus 8 is 20, so that works. And then -5 times -4 is 20. 20 minus 1 is 19, so that works. All right. So this next example, number 4, if I look at my system here, I've got a coefficient of 1 in front of the y, so I'm going to solve for y. Y is equal to x plus 3. I'm going to circle my y in the first equation. I'm going to substitute in x plus 3 for that y. So -3x plus 3 times x plus 3 equals 4. I'm going to distribute that. All right, now what happens when I combine my like terms? These cancel out. I'm left with 9 equals 4. Well, I know that 9 does not equal 4, so this is an example of no solution. Okay. Now going ahead to number 5. Number 5, all right, we don't always have to have X's and Y's. We can have A's and B's. All right, so in this case, I don't have any examples of a coefficient of 1, but I do have a coefficient of -1, so it's probably easiest to solve for just B in the second equation. So I'm going to do that. I got negative B equals negative 2A plus 5, and then I'm going to divide every term by -1. B is equal to 2A minus 5. All right, so because I solved for B there, I'm going to circle my B, and now that's where I'm going to substitute. I got 2A minus 5 equals 7. I'm going to distribute this. Okay, equals 7. All right, now I'm going to combine my like terms. I've got negative 4A plus 15 equals 7. And now I'm going to subtract my 15 from both sides. Negative 4A is going to be equal to a negative 8. I divide by negative 4. My A is 2. Okay, so I got my A. Now to get my B, I'm going to plug in, and B is going to be equal to 2 times 2 minus 5. B is 4 minus 5, which is -1. So my solution, I'm going to say, is 2, -1. I'm going to put my variables in alphabetical order. So I did it A, B in that case. Okay, so there's my solution. All right, so looking at number 6. Number 6, well, my y is already solved for me, so it makes it easiest to just circle the y in the first equation and substitute in 2x minus 4. 4x minus 2 times 2x minus 4 is going to be equal to 8. We'll solve for x. All right, but when we combine our like terms, these cancel out. We're left with 8 is equal to 8. That's true. So because it's true, I know I have infinite solutions. All right, so you have 4 examples, and then of having one solution, and then an example of no solution, and an example of infinite solutions. All right, so now I'm going to teach you how to go through the word problems. All right, the key to the word problems is identifying the variables, okay, and using your let statement. So the first statement says, find the value of two numbers if their sum is 12 and their difference is 4. So I'm going to let x be my first number, all right, and y be my second, because I don't know what they are. They're my variables. Okay, first number, second number. Okay, their sum means if I add them together, I'm going to get 12. Well, I can write an equation for that. I take x plus y, and I get 12. But their difference is 4. So if I take x minus y, I'm going to get 4. Okay, notice 2 variables. In order to solve for 2 different variables, I need 2 equations. Okay, so all your word problems in this unit you'll be looking for 2 equations in the words. All right, now I'm just going to use substitution. Okay, and I have a lot of coefficients of 1 here, but I'm going to solve for the first one for x is going to be equal to negative y plus 12. All right, so I circled that y. Oh, sorry, I circled the x. I meant to circle the x. Don't want to confuse you. X minus y is equal to 4. All right, so since I solved for x here, I'm going to circle my x there. And now I'm going to substitute in the expression negative y plus 12. So negative y plus 12 minus y is going to be equal to 4. All right, we now want to combine our like terms. Negative y minus y is negative 2y plus 12 is equal to 4. And then we're going to subtract our 12 from both sides. Negative 2y is equal to negative 8. Okay, our y is going to be equal to 4. Okay, so we found our y. Now to get our x, we simply plug in. We get x is equal to negative y, or negative 4 plus 12, which is 8. Okay, so our first number is our x, which is 8, and our second number is y, which is 4. Okay, so always make sure you answer the question. So when you have word problems, you're not going to have an ordered pair as your solution, but you have to identify the 2 numbers. And if you think about it, if you take 8 and 4, add them together, you get 12, and if you subtract them, you get 4. So that works. All right, so number 8, your brother and sister took turns driving on a 635-mile trip that took 11 hours to complete. Your brother drove at a constant speed of 60 miles per hour and your sister drove at a constant speed of 55 miles per hour. This one's telling you your let statement. Let X be the number of hours your brother drove. So let's do let X be brother's hours. And we're letting Y be sister hours. Oops, horse? I don't know what I wrote there. Hours. Okay. All right. So there's our let statement. Okay. So we know we have two variables. That means we need two equations. Okay. Sometimes the easy equation is kind of hidden in there. All right. The trip took 11 hours. If the trip took 11 hours, that simply means that if I take my brother's hours and my sister's hours, I get 11. Okay, there's the easy equation. The second equation has to do with driving 60 miles an hour. So your brother drove at a constant speed of 60 miles an hour. So 60 times X, okay, and then the sister drove at 55 miles per hour. So 55 miles per hour, which would be 55Y, and they drove 635 miles for the whole trip. Okay, so there's our equation. All right, we have two equations, two variables. Now I'm going to use substitution. I'm going to solve X is going to be equal to a negative Y plus 11. Okay, I solve for X in the first equation, so I'm going to substitute it into the second. 60 times negative Y plus 11 plus 55Y is going to be equal to 635. All right, I'm going to distribute negative 60Y plus 660 plus 55Y, and that's going to be equal to 635. All right, I'm going to combine my like terms. So I have negative 5Y plus 660 is equal to 635. Now I'm going to subtract the 660 from both sides. Okay, and when I do that, negative 5Y is equal to negative 25. I divide by negative 5, and my Y is going to be 5. So I know my Y is sister hours, so 5 hours for sister. Okay, because we're finding out the number of hours each drove. Now to get my brothers, I simply plug it back in, and I get my Y. My X is going to be equal to negative 5 plus 11, or my X is 6, and 6 hours for the brother. Okay, so the key to this is really the let statement. Two variables, two equations. Let's try one more. All right, the members of an outing club take a day-long tubing trip down the river. The company that offers the tubing trip charges $15 to rent a tube for a person to use and $7.50 to rent a cooler tube, which is used to carry food and water in the cooler. The club members spend $360 to rent a total of 26 tubes. How many of each type of tube do they rent? All right, so let's let P be the person tube. A lot of times I like my variables kind of line up with what we're looking for, the number of person tubes. And let's let C be the types of cooler tubes. Okay, to put food and drink in. All right, so we're renting a total of 26 tubes. There's my easy equation. Person tubes and cooler tubes is 26. Okay, but now we have the money one. Okay, it's $15 to rent a tube for a person. So every person tube is $15. It's 15 times P. And the cooler tube is $7.50 times C. And that's going to be equal to how much money? $360. Okay, so now we have our two equations, two variables. All right, we're going to start by solving. I'll solve for P. You could solve for P or C, but P is negative C plus 26. Because I solved for P there, I put that in there. Okay, and we're going to now distribute. So 15 times negative C plus 26 plus 7.5C is equal to 360. Okay, so we're going to distribute negative 15C and 26 times 15. Okay, a little old-fashioned math here. 0.6209 390. Okay, so we got negative 15C plus 390 plus 7.5C is equal to 360. We're going to combine our like terms, and we get negative 7.5c, okay, plus 390 equals 360. I'll subtract my 390 from both sides. Negative 7.5c is equal to a negative 30. Okay, so when I divide both sides by negative 7.5, we get c is equal to 4. Okay, so we have 4 cooler tubes, and then to get our person tubes, we plug it back in. P is equal to negative 4 plus 26, which is 22. Okay, so there's our answer. 22 person tubes, 4 cooler tubes, total of 26. All right, so try the exit ticket and have a good day. Bye.